University is demanding. Mid-semester exams, end-of-semester exams, weekly quizzes and fortnightly assignments take their toll. In result, lectures are often skipped or simply slept through. Lucky we live in a world that comprises of thousands of molecules, but more so, this unique compound referred to as caffeine. And like numerous students, I turn to the world's most psychoactive drug when I acquire an instant kick of energy. Having a half-life of somewhere between 2.5 to 4.5 hours, it's no wonder I find myself drinking more carbon, hydrogen, nitrogen, and oxygen than the simple H2O combination. Caffeine, otherwise known as trimethylxanthine, is naturally produced by several plants including coffee beans, guarana, yerba mate, cacao beans, and tea. However, to really find out how caffeine does what it does, we must look into the substance itself. Hosting white crystalline xanthine alkaloid properties, the chemical structure of caffeine is as such. Constituting of 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms, the total molar mass is equal to 194.19 grams per mole. Caffeine bonding is solely covalent, which involves the sharing of electron pairs between atoms. The compound caffeine constitutes of 3 molecular shapes. A bent shape is formed when the nitrogen bonds with 2 carbon atoms, resulting in a lone pair of electrons. This nitrogen creates 3 single bonds with carbon atoms, leaving 1 lone pair of electrons. This bond forms a pyramidal shape. The molecular shape that is formed by the 3 carbons and the hydrogen is that of tetrahedral. The final bond, that also being tetrahedral, is when the carbon bonds with 2 nitrogen atoms, of which create a double bond with oxygen. Caffeine has both polar and nonpolar bonds. The hydrogen and carbon create a nonpolar bond, while the bonds between carbon and nitrogen and carbon and oxygen are polar. This image shows the different levels in electronegativity, where the arrow points from low to high values. So why does caffeine give us that much needed hit of energy? Caffeine is very similar to another molecule in the brain known as adenosine, which has the effect of drowsiness. Caffeine blocks the receptors in the brain before the adenosine molecules can get there, counteracting many of these molecules. Simply put, caffeine tricks your brain into thinking you aren't tired. People, including myself, love the feeling of alertness provided by caffeine. It is important to me at every moment of the day. It's beneficial before working out and extremely beneficial come exam time. I don't know about you, but I'll be a coffee drinker for life.